Okay, let's talk about changes of state. So there are 6 changes of matter we're going to talk about. Before that, but matter can change from state to state without changing its identity. And again, there are 6 ways matter can change. The first one is melting. Melting changes from a solid to a liquid, like ice melting into liquid water. Opposite of melting is freezing. That changes from a liquid to a gas. That's just like making ice. We freeze liquid water to make our solid ice. We also have evaporation. That changes from a liquid to a gas. So if you're making ramen, you're boiling water, you start seeing that smoke, that steam. That's having that liquid water being converted into steam, which is water gas particles. Oppositely of evaporation is condensation. Changes from a gas to a liquid. Happens when it rains. Rain is a form of condensation. Also, if you're outside and you have a nice cold glass of water, it starts to sweat on the outside of the glass. That's not the liquid inside of your glass, your drink. It's actually the gas particles, the water particles in the atmosphere being changed into a liquid onto your glass. We also have sublimation. Now, sublimation changes from a solid to a gas. It skips the liquid phase. We see this in dry ice. Dry ice is usually found in the freezers in the ice cream parlors. So if you get some ice cream at an ice cream parlor, they open up that kind of glass fridge container and you have that white smoke coming out. That's that dry ice becoming into a gas, because dry ice is actually frozen carbon dioxide gas. And the opposite of sublimation is deposition, and that changes from a gas to a solid. Now, during a change of matter, there is a temperature change in which heat causes the change by adding or removing energy. And all of this can be represented with a phase change diagram. So let's look at what phase change diagrams look like. We have the melting point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. So we're going to draw the phase change diagram for water. First, you need to label your y and x axis. Your y-axis is going to be temperature. Your x-axis is going to be time. Now you see how 0 is much lower than 100? 0 is going to go first on your y-axis. So go to put a dash somewhere in your y-axis and put 0. And label 0 as your melting point. This represents your melting point temperature. Now your boiling point is 100. And let's label that as your boiling point. Now for a phase change diagram, there's going to be 3 diagonal lines and 2 straight lines. We're going to do a diagonal all the way until it hits our melting point. And then we're going to do a straight line. Then we're going to do a diagonal line from our melting point to our boiling point. Then a straight line. And then we're going to do our diagonal line again. Now, each of these diagonals and straights represent either a state of matter, solid, liquid, or gas, or a change of matter that we just talked about. Our 3 diagonal lines represent a state of matter. Our first diagonal line actually represents a solid. Second one is a liquid. Third one is a gas. Now, these straight lines represent our change of matter. So going from a solid to a liquid, this first straight line, if we're going from a solid to a liquid, represents melting. And if we're going oppositely, we know opposite of melting is freezing. And if we're going from a liquid to a gas, that's evaporation. And opposite of evaporation is condensation. Now, we just learned about 6 phase changes of matter, changes of state. And that is deposition and sublimation, and we could just add that there. Now that we kind of know where our changes of matter, our states of matter are, we can start talking about energy. Now, as we're going left to right on our graph, we know the temperature is increasing. As temperature increases, energy is being added, and that's where the idea of heating comes into play. So when you're recording temperature, you're recording how fast particles are because it's being heated, because energy is being added. Now thinking oppositely, if we're going down the graph, energy is being removed because there's a cooling going on. So with all that in mind, as the temperature increases, the particle speed increases and are spaced out. And we can see that with our diagram of our solid, liquid, and gases. They're becoming more spaced out as we go up, as the temperature increases. And oppositely, as the temperature decreases, the particle speed decreases and are becoming closer together. So with that idea, let's go ahead and do the phase change diagram for ethanol. And we know the melting point is negative 114.5 and the boiling point 78.5. Again, labeling our X and Y axis, we have temperature and time. And remember, melting point is going to be a lot lower than boiling point, so we got to do our melting point first, then our boiling point, and just do our diagonals up until we hit our melting point, then a straight line, diagonal line until our boiling point, straight line, and then diagonal line again. And that is your phase change diagram. And that's it. Thanks, guys.